All right, we're continuing on from yesterday. So you guys just worked through the second example. Second example, we got constant over 0. With our constant over 0, we know it has to be non-removable. We know that it has to be a vertical asymptote. And so therefore, you guys started to solve. Which direction did you come from first? Okay, so if we come from the left, what could be a constant from the left? We'll just say f of x. A constant that you could have plugged in. Ooh. It's always kind of hard to think about the negatives. I don't know why, but it is. Now, technically, could you maybe have picked something far removed and still been okay? Maybe. But if I'm trying to get really close to this, what is something just barely removed from -1? -1.01. Yeah. Or 0.001 or maybe -1.1. I try to get kind of close just to make it super obvious to me. Now I'm putting a little colon instead of an equals because technically this isn't solving for the limit. This is finding or checking the sign. So therefore, if I plug in, I get -1.01, for instance. -1.01 plus 1. If you want to do another way of doing this, but this way is a little bit harder because it's a little more abstract, you could do -1 minus. It's like, oh, it's a little bit less than -1, but with negatives, that's kind of tricky, which is why I just pick one, just to make it a little bit easier on myself. All over -1.01 plus 1. What'd you guys get as your signs? Positive over a, so therefore I'm going to have, it's going to approach -infinity. Does that make sense? Then I come from the other direction, the limit as x approaches 1 positive of my function, and I get, oh, -1 positive. Oh dear. There we go. That looks awkward. What's something on the other side of -1, guys? Yeah, that would what? Oh, that's not close. There we go. -0.99. Did you do 3? Sure. So I have -0.99. Some of you might already be able to tell in this example what the signs are going to be, but this is strictly just for you to think through it and see it like right there. Oh, okay, the top is going to be a, and the bottom's going to be a, so therefore I'm approaching. So, what is my limit? Jezreel, say it loud and clear. Got it. The limit does not exist because the one-sided limits do not agree. It's okay, we're trying. E for effort. Couple more seconds. The limit does not exist. All right, so what were we talking about on this page? We are talking about vertical asymptotes. This page, we are talking about poles. So let's go ahead and give those names because those types of discontinuities, what happens when you strive to take the limit, we can actually kind of name them with their forms. You guys, I think, saw these last year, I'm pretty sure. At some point, at least, you saw this last year. Indeterminate form and infinite form. If I am trying to find the limit, I always try to plug in. And of course, both of these do not exist, but they don't exist in different ways. Indeterminate form would give me 0 over 0. Infinite form would give me some constant. I'm just going to put a number sign, so I have to use an awkward variable. Infinite form would give me a number over 0. As you guys just saw, I have us write little reminders just to help us out. So 0 over 0, indeterminate form, keep going. We're going to see some other ways of how you can keep going besides just factoring. So far we've just reviewed factoring. Infinite form, there's going to be a vertical asymptote. Now, of course, there are just a couple exceptions to this rule, including like piecewise functions and absolute value functions, funky ones that are going to kind of give us a run for our money, but we can still do them. So hang in there. But right now, specifically with polynomials, with radicals, with rational functions, all kinds of weird stuff like that, we can group them together in indeterminate form. It's going to be removable. Unless we have trig, but we're still going to see how to do that today. It's going to be removable, so we're going to keep going. We're going to try to simplify. Infinite form, we know it's going to be a vertical asymptote. It's going to be non-removable, so we don't keep looking. Instead, we just evaluate. We search out that function. We try to figure, okay, which infinity is it going to? kind of sum up all the discontinuities that we've seen thus far and what we do with them. If you get a 0 over 0, what do I want you to write?
Keep going.
Keep going. If you see a constant over 0, I want you to write
VA.
vertical asymptote. Just to remind yourself. Sometimes we need those reminders to stop us from going wrong. There's a life lesson in that if you look deep. Okay, keep going. Piecewise functions. Woo! What do we do if it is approaching a separator? So I'm going to totally go steal that function that we saw and have it, instead of approaching 2, we're going to come back. Instead of approaching 2, he's going to approach 0. I'm going to put a colon, because if we're approaching a separator, we're going to have to come from each side. So another example of a double-sided limit. Double-sided, because I have to come from each side. Guys, why don't I just say, hey, he's equal to 0 on this piece. Plug in 0, done. There is some reason why. Why don't I just look to see where 0 is in the domain and say plug him in? Yeah, I'm trying to approach 0. F of 0 I just plug in, but approaching 0. I have to come from below. I have to come from above. I have to come from below. I have to come from above. Is algae gone today?
I just saw him.
Oh, maybe it's not this one. Okay, guys, approach. Come from the left, come from the right. You know how to do piecewise. You saw it a couple days ago. And then compare and see if they agree. Every fifth period. I know. Ignore me. MTS Optimus Christensen. Come from the left, come from the right. See what happens. Come on, my ones. Just sit. You can do it. You got this. Come from the left, come from the right, and then compare. Come from the left, come from the right, and then compare. Come from the left, come from the right, and then compare. Press, I'm putting your papers in row 1. Okay. Sunny, where are you? There you are. Ariel, where are you? Oh, okay. Couple more seconds. Try to do it as perfectly as you can. We'll see if you got it. If you can, check with someone in your group real quick if you're done early. Talk about it just for a second. Yeah. Oh, ask it from there, buddy.
Yeah, I need to get it.
Okay, go ahead.
I asked them how to take out their what do we use the first one? Because or equal to?
So the top one is below it, the bottom one is above.
So will we use both? So we use both.
But one at a time. So you gotta come from one side and then the other. So then, kiddos, as I come from below, I'm guessing we do that first, right? As I come from below, question, which piece am I using? Does it come from below? The first one, right? So I'm using x squared minus 1 because which piece is talking about numbers that are below 0? Now, is this equal? Yes. But I'm trying to approach f of 0. Plug in here, done. But I don't want the function value, I want the limit. So then, take the limit of, and you guys got from the left? Not that hard. Plug in 0. 0 squared minus 1 is negative 1. As I come from above, where am I plugging it into? So therefore, my limit is going to be 2. And if I want my overall limit, now I compare the two. And comparing the two, they do not agree. So if they do not agree, then my limit, what's my limit?
D and E.
Why? Because of the work shown below. Any questions on piecewise things? Emily? Because remember, if there are no holes or vertical asymptotes of a function where I am trying to take the limit towards, so I can plug in 0 to the top, no problem. I can plug in 0 to the bottom, no problem. And so I'm going to use that direct substitution way of saying, oh, I can plug in, so let me do it. I just have to remember, piecewise separator, I have to come from below, because that's the top, and above, that's the other one, and compare the two. Because I'm having two pieces coming together, this puzzle doesn't fit. So they're not going to match up perfectly. Does that kind of make sense? Keep pondering. Benji, go ahead.
So they like push it here. They have to do both sides, right?
Both sides have to agree. And since it's the separator, the numbers below and the numbers above. If you guys want, I can even show a graph real quickly to kind of help us out with the idea. We know the first part. For all the numbers, including 0 and below, are going to be a parabola at -1, right? Okay? Does everybody agree that's the first piece? Okay, what's the second piece?
Up to.
So what am I doing? The limit as I come from the left is -1. And the limit as I come from the right is 2. But do they agree? So this is an algebraic expression of some of those funky graphs that you've seen before. All right, we move on. Other simplifying. What if you have a nasty radical and you're like, oh, how do I simplify that? No. Factor. Some of you could. A lot of us couldn't. Some of you could, a lot of us couldn't. If I said to factor, so what's another way to get or to move that radical out? Conjugate. What am I trying to get rid of? Well, hold on, pause. Why am I even doing anything? Just plug it in, right, guys? What happens when you plug it in? What does 0 over 0 always mean? All right, so there's bound to be a way I can simplify this puppy. Some of you would see a difference of squares in the numerator. Awesome, go with that. Some of you were like, that's not a difference of squares. Okay, let's go a different way. So a different way would be multiply both sides by the conjugate. Conjugate, remember, needs to be the exact same term, but with a plus instead of a minus. And what I do on top, I have to do on bottom. Now I tried to plug in, it didn't work, so I have to go back to writing limit again. If you stop writing limit, all of a sudden you're not taking a limit, all of a sudden you've lost track of the end goal. So we're going to keep on writing limit until we can plug in and until we can solve. I'm writing it again, so should you. If you don't, I'm going to start taking off points because you haven't taken it yet if you're still simplifying. When I simplify, let's simplify the bottom first. Difference of squares, I get 4 minus y when we do first, outer, inner, last. What do you guys notice about with what we had originally? It's the same. So I'm not going to go foiling the top. That's going to totally be counterproductive because I want to be able to say, ha-ha, he had a common 0. Look, I found him. There he is. Ta-da. And whenever we reduce, there's a 1 left. What did I do again? Difference of squares on the bottom. So 2 times 2 was 4, plus 2 root y, minus 2 root y. That canceled. A negative times a positive root y is a negative y. Square root squared cancels out. Negative is the sign remaining. Then the 2 matched. Now I'm going to stop writing limit because what can I do now that I've gotten rid of my discontinuity? Plug it in, and now I have my limit. I ignored the hole, and I found what it's approaching. The y value is approaching. So how am I going to fill in my blank up above? Multiply by the
conjugate.
That could be a trick. That could be a trick. 2, other simplifying. 2, creative simplifying. 2, not just factoring, and yet still trying to keep going. Yeah? So what if I gave you something like That's a B. That means it's another one. Still other simplifying, still being creative. But guys, look at it. First of all, plug it in. What do I get? 0 over 0. Because 1/2 minus 1/2 all over 0. So I'm bound to be able to keep going. But who wants to factor? Not me, and hopefully not you either. Because if you try factoring that puppy, something's going to go really wrong. Factoring, no. Multiply by a conjugate? Do we really want to put more fractions in that complex fraction? I don't think so. Simplify that complex fraction. Didn't we review that like a million times? Not really, but at least a few dozen. Complex fractions. Simplify. Simplify into one common fraction. You guys should know how to simplify, right? Should. Definitely should. As you guys are working through this problem, I'm going to come back in just a second. But right now, you are getting your chapter 1. Your chapter 1 quest. Now, if you got below a 28, that means you got below a 70. 28 out of 40. 28 out of 40. 28 out of 40. If you got below a 28, there is going to be an extra credit opportunity during lunch on Thursday. Stink. Something's going on during lunch on Thursday. What's going on during lunch on Thursday? Student council meeting? What? No, it's not meeting. You should be there. Talk to me if for any reason you can't make it Thursday during lunch, but I want to make it Thursday during lunch because then you have an extra day to ask me questions. Does that make sense?
So.
And after school, you're all going to be like running away to go decorate Spirit Day shirts or something. So
Yeah.
we're going to do Thursday during lunch, but if you can't make it, let me know and maybe we could do Wednesday after school. Okay? So if you got below a 28, that opportunity is open to you because you got below a 70%. Another reason why I'm opening it up. Just because some people did that. No, not just because some people did that. This is the first test some of you guys have ever had with me. Some others of you, we squished a lot in. We basically reviewed all of pre-count and took a test in it all a week and a half after school started. So, might have been a little bit too intense, or maybe you just got too overwhelmed with other classes you didn't get to study. Maybe you thought it would be a lot easier than it actually was. I don't know. There are lots of reasons. So if you want to talk to me about how I feel about your capability in this class from this class, please give me a chance to talk to you about it and to look at what mistakes you made, etc. And once again, there are many different reasons, but there is going to be an extra credit opportunity for those who got below a 28 out of 40 on Thursday during lunch. All right, kiddos, you were supposed to be working on this complex fraction, right? So what is our goal? To get it to one fraction. We have to somehow do common denominators, right? Somehow or other. If you were doing it my way, some of you figured out my way in the summer packet. If you were doing it my way, what would you multiply top and bottom by? Yeah, the two denominators. And what are the two denominators? You guys got a little bit of water down there? My water's still sorry. If I multiply top and bottom, There are different ways of doing it. There are different ways of doing it. You could say times 2 over 2 times 2 plus x over 2 plus x and go through this huge simplifying process. Or you could do my really cool shortcut if you understand it. Just don't forget to distribute. And I end up with, why am I still writing limits? Because I haven't taken it yet. I tried. It was 0 over 0. It didn't work. If you didn't write limit again, write it again right now. The first time, he's going to cancel with the one that's the same. So there's going to be a 2 left over. The second time, the 2's will cancel, and I'll have a, don't forget your grouping, a 2 plus x. Don't forget it. The bottom, the x times the 2 plus x. Don't forget to distribute your negative. It's one of those easy mistakes that just always just throws us off. Distribute that negative. The nice thing is, can't I keep reducing? What's left when I reduce? 5 over 5, 1 over 1. If I have 10 pieces out of a 10-piece pizza, I have the whole thing. I have 1, not 0. Right? Now, I'm not going to keep writing a limit because what am I going to do? How many people got negative 1/4? Few of you. Thank you. Good job. Those that got stuck. Questions? Those that got stuck. Questions? Okay, so what if we had another 0 over 0, but I can't factor? Did anybody try to start AP number 2? It's okay if you didn't. It's totally okay if you didn't, because that means you didn't get as confused. But if you did try to start AP number 2, which isn't due until next Tuesday, if you didn't try to start AP number 2, when you do try to start it, there might be some trig. And here are the special trig ones that you might see. Give me a couple seconds. There are 2 fundamental trig limits that help us when, hold on, this is the weird category, 0 over 0, keep going, but how? This isn't limit as I approach pi over 6, I plug in pi over 6, I have an answer. That could happen as well. But special trig limits. If I have sine of some expression u, it could be sine of x, it could be sine of 3x, as long as it's over that same expression, whether it's sine of x over x, sine of 2x over 2x, sine of 3x over 3x, that limit will always equal 1 as my expression approaches 0. There's one other special one. The limit as u approaches 0 of 1 minus cosine of u over u equals 0. There are a few different ways of memorizing this. I'll talk about that in the future, but for right now, these are super important. Whenever you see trig and plugging in doesn't work, that's why we're calling it forever number 2. Nice thing is, it's a lot shorter than number 1. Okay? And then if worse comes to worse, this might not be enough. You might need to use some properties to simplify. Some examples might be multiplying by 1 creatively, or use trig properties, and hopefully you'll be able to see what I mean. Still a few more minutes. Don't start packing up yet. Okay, so if I was to give you the following. That's awkward. couple seconds as I finish passing out the last of the requests. Other side of the room. Max, you're up here. Matthew. Woo! All right. Remember, if you got below a 28, come ask me questions and get ready for the extra credit opportunity on Thursday during lunch. Kiddos, the first one. Sine of u over u. If I plugged in, I would get sine of 0 over 0. Yeah, it doesn't work. Keep going. But how? Use the special trig limit, which means, wait, 2x isn't approaching 0. Divide both sides by 2. Oh, it is. It equals 1. Hold on. Next one. Ah, they don't match. But I can make them match. I can make them match. It technically is a 0 over 0. Keep going, but I'm making them match. How does that help? Well, I saw from my limit properties I can bring things out, not change what they're doing, but I can take constants out of a limit, and then I end up with, does this match now? 1 minus cosine of u over u? Yes. What is this going to be approaching? So then, you might say, well, I should have known it was 0 from the get-go. Doesn't always work like that, so be careful. However, we wouldn't have been able to do it with factoring, multiplying by a conjugate, simplifying a complex fraction. We have to use those special trig limits. So the last one of today is, it doesn't fit. It doesn't fit, it doesn't fit, it doesn't fit, it doesn't fit. But wait, it's still 0 over 0. Hold on. What's tangent?
Sine over cosine.
Oh. So really I could make this sine of x over cosine of x all over x, which I could simplify. Hold on, give me 2 seconds, and you guys will have bypassed period 1, which is good since we were behind. Sine of x over x times 1 over cosine of x. Who's that? Where'd he go? 1. Special trig limit. So then my answer is 1 times 1 over cosine of 0, which is... Wow. Woo! All right, cool kids. I'll see you tomorrow. Work on section 2.2 homework tonight. If you have any questions on things, I will be here till about 3:30 today. Then I have to go find a dentist because otherwise he gets mad at me. Bye, cool kids. I will see you later. Work on your homework before the AP. Work on your homework first.